Okay, I think it's time. Maybe we should get started. Okay, so hello everyone. Welcome to the IETF 122 IV Working Group meeting. My name is Jiu Fang and my co-chair Daniela. We will be running this meeting together. Unfortunately, both chairs are remote this time. Rob kindly accepted our request to help as a delegate. Thank you, Rob. Please be aware that this session is being recorded. And this slide is about the Note 12. This is actually a reminder of a set of IETF policies and rules that you should be familiar with this. By participating in the IETF, you agree to follow IETF processes and policies. You have also please ensure that you are aware of the requirements for RPR, the disclosing RPR, and our code of conduct, and the way we treat each other. If you are not familiar with this or you have any questions, please feel free to reach out to chairs and ADs. And again, the ISG has asked all chairs to remind their working groups of the need for appropriate behavior, and please make sure your comments are on point and give full respect and courtesy to our colleagues. And we should really focus on the impersonal and technical discussion. And this is about the IETF 122 meeting tips for both the in-person and the remote participants. We use the Meet Echo to join the meeting. If you are if you are on site, you could use the Meet Echo line to join the mic queue to make a comment and participate in the show of hands. And if you are using the on-site version, please make sure to keep your audio and video off. For remote participants, please ensure your audio and video are off unless you are chairing or actively speaking. Okay, so this is about the note-taking. I guess we need 1 or 2 volunteers to help us capture the discussion, and please feel free to help with the notes. And our today's session will be a 2-hour. So the meeting materials are available at the link below. So again, this is a final reminder that we work remotely most of the time. So everyone, please make use of the mailing list to determine the working group consensus. And it's also the mailing list, please use it to resolve your open issues, review changes to working group documents, and introducing your new drafts and ideas, and also discuss any potential new working group topics. We could also have arrange a set of virtual meetings as needed. Could also be periodic. So if you wish some topics to be discussed, please feel free to make requests to chairs so that we can arrange for you. And we also have some working group WebEx meeting resources. So any working group members can make a request to chairs. Currently we have the inventory-based model design team to use the weekly call for discussion. And please be aware that these meeting resources will be announced on the mailing list, and everyone should be everyone is welcome to join the meeting and participate in the discussion. And here is our agenda today. As usual, we don't have a packed agenda, so which means we could have some full discussion, and we don't need to strictly follow the time limits. So, but chairs may observe and remind the working group of the time at the proper moment to ensure fairness for all presenters. Just be aware of this. Any agenda question? No? Okay. So
We
would you
might
like to
have
go?
we might have a bashing on the fly because Diego is busy with the two different working groups, so we might need to swap his presentation if he joins us late. Just an heads up. We will be flexible between slots 4 and 5.
Yeah. Diego might be need to be involved in two meetings, so we need to give some flexibility here between them slot number 4 and number 5. Yes. Okay, the working group status would like to go ahead, Daniela.
Yep. So this is going to be very quick. So for the base model, it's work in progress. We have design meeting with weekly calls as usual. There you find the link if you wanted to join them. The document did many good progresses. We are getting closer to a solid enough document for working group last call. So I don't expect the working group last call of the document to be that far away. The authors did a very good job in defining which open issues need to be solved before the working group last call, which ones can be solved at later stages, maybe with the second draft, and which ones can be deferred. So a lot of work has been done in that direction. Then we will see an update on the network inventory topology by the authors, while the two other working group documents will not be presented at this time: the network inventory location and the network inventory software. We received an update from both on the mailing list. So regarding the network inventory location, this was adopted right before IETF 121. There is a number of open issues that were raised during the adoption. They have been tracked in GitHub. One of them was raised by Iowa. He proposed the location type as a floor definition from BBF. But there is still some discussion. We have not reached the consensus yet. Regarding the network inventory software, on the other side, that was adopted by the working group after 120. IETF 121 as well, but there are no big open issues raised. The plan from the authors is to keep the document consistent with the base inventory and keep on working on that. I think next one. I think we are done with the admin slides. Yeah, this was very simple. Any question from the floor, from the working group, or we can move to the first presentation? Perfect. Please, Aya.
Yes, I just pass control to the slides clicker so that I think the clicker can be used.
Okay, thank you, Chufang Danieli. So this is Iowa. As a contributor, I'm presenting this work for network inventory Young on behalf of the co-authors and the contributors. Here we go. So here's a list of updates which has already been put on the mailing list. Since IETF 121, we did some updates to clarify the terminology and scope, and also it basically to clarify that this model applies to, it's not limited to the ACTN scenario, but could be more generic. And the model is also designed to be technology and application agnostic. And for this version, it only covers the actual active inventory and not about intended or planned inventory, as we have discussed in the beginning. The model, the YAM model was also updated, basically by adding a few things. The first is the navigation of from child components to its parent component, and also updated the model for ports, transceiver, and the breakouts. We have a lot of discussions on the mailing list as well as within the design team, and the updated model is done to reflect the discussion. Also, there's some optimization defining reusable groupings for network elements and ports and the breakout channels, so that can be reused, by anyone who augments the model. And also added some appendixes to provide some examples for ports, transceiver, and breakout configurations. But note, they might need to be improved further. And also, along with that, an example of the JSON is also included. Yeah. So we are still working on some open issues. So here is a list of priority 1 issues. Basically, we need to complete an example for breakout configurations. We have all the pictures, as you will see in the next couple of page presentations, but there needs to be converted and put into the text. Also, the definitions of slot versus subslot, as well as the shelf and subshelf, and which is also known as chassis or sub-chassis. We need to give some examples of the network element with multiple shelves or multiple chassis. We also received comments from the mailing list regarding providing some guidelines for future augmentations on this model. Thanks a lot, Matt. That we are still discussing, and probably will have some more discussion on the mailing list regarding how we can do that. And also, there are additional attributes that are under consideration. For example, we already have the child to parent navigation, but what about parent to child reverse navigation? Whether we need to have that included in the model, it needs some further thoughts, and also provide things like a system level name, well, system name or software name at the network element or device level, and also some additional attributes imported from RFC 7317, along with the security consideration, of course, and some cleanup on the. So we discussed a lot about the modeling of ports. And there are different thoughts. And eventually, we converged on how the ports can be modeled. So we are looking into basically at least 4 scenarios. One is the first one being a non-pluggable or an integrated port that on a card, right? Which is non-pluggable basically. And then the second one is a port with an empty hole, basically with no pluggable transceivers inserted. And the third case is a pluggable is a hole with a pluggable transceiver inserted into the slot. And the last one is also a non-pluggable port. But the difference is the transceiver is not shown here, which is different from the first case, and whether or not we need to model the transceivers probably needs some further discussion. So today we're only focusing on the first three port examples. So this is the modeling for a pluggable port where a board has a child component of a port, and for the port, it's not pluggable because it's already exists on the board. But then its child component called the transceiver, which is field replaceable. And depending on the configurations of the capability of the transceiver, it might have a list of breakout channels as its child component. And for this particular port, it will be covering various types of ports like electrical or an optical port with a single channel, or a WDM port with multiple WDM channels, or an MPO port with multiple channels. Both for the WDM and MPO, it can model with the ports with or without breakout. So the locations can be sort of inferred by navigating from the parent down to the child, or the other way around, right? So basically, you can build up a location type of string based on the relative positions from the child back to the parent. And so the next is a non-pluggable integrated port. Basically, the only difference with this and the pluggable port is that the transceiver module is not field replaceable. So the parameter is FRU is force, and the rest of them are the same. And also on the modeling of an empty hole, as you said, there's this port component still there, but there's no child underneath. Because there's no child transceiver module component currently inserted. Yeah, so here we give some examples of the ports that as I said, we wanted to convert this drawing into some good examples of different types of ports with or without breakout channels. So this is a single line interface optical port, and on the left it's the host interface host part of the port, and on the right is the transceiver. So in this case there's no breakout channels reported because the port does not support the breakout. This example about on the line side of using MPU breakouts, but on the host side has the capability for breakout channels. And in this example, it has 4 breakout channels, 1 for each of the line channels. So this capability will be reported in the inventory. And yet another example with the MPU, but on the host side, we're not breakout the channels. But note that so in this case, even if we don't we don't configure the port in breakout mode, it still has the capability to perform breakout. So this, in this case, 4 breakout channels are still reported in this case. Yeah, so the same, again, it's the same. The only difference is the line, on the line side for this port, it's using WD multiplexing. So we have some discussion to provide some guidelines for future augmentations. The comments were received on a mailing list. However, you know, we are as authors are still think that it may be a bit hard to predict the need for augmentations, and in that case, if we provide a guideline, it could be either too restrictive or too liberal, which does not reflect the actual need, right? And as a matter of fact, but at the bottom line is we already have some sort of gesture or indication in the model that can be used to as an input to provide some guidelines. So, for example, when we define a container, like in an empty container for port-specific attributes or for board-specific attributes, those already implies that there's a guideline that you would need to augment the model and put the attributes, augmented attributes, under that same container. So those we can explicitly point it out, but for additional guidelines, maybe we need some more research into that, and also plan to look into some existing examples and see, find the best way for filling out the guidelines. So, in this case, input from the mailing list or from contributors are really helpful. Please, Mahesh, you want? Yeah.
Mahesh, speaking as a contributor, if you're looking for examples on how an augmentation can be made to happen, you can go and look at the BGP Yang model. Okay. It has an example of how, of course, it's with respect to the BGP protocol, but it shows an example code of how it can be augmented. Okay. So that's one way to look at it. But I think in this particular case, and I'm kind of putting on my AD hat a little bit also, is that I believe the base specification should be as simple as possible, so we can get it through the working group and defer most of the augmentation to the other documents. So I think guideline is good, and thanks, Med, for providing some of the comments. We should do that, but let's keep it to an example of how that augmentation can be made to happen.
Okay, yeah, we'll look into the example that you provided, and probably we'll come up with descriptions as concise as we could. Okay.
Yes, I think following the Mahesh suggestion, I think the software component extension already provides some example there, and also the inventory topology. Yeah. We are also doing the augmentation based on network inventory to provide navigation, bi-directional navigation. So yeah. I think you can refer to that as some examples here.
Yeah, yeah, okay. Yeah. I think the point is to reflect this, in some way, add descriptions and refer to those examples in the base model. Yeah. Joe.
Joe Clark, Cisco. Few comments. One, I like the parent ref or the parent child. I think you asked, do you like? I like that change. I think that sits well with my old entity experience, so I like that, moving from child to parent. I read your changes. I guess I'm coming around to this whole breakout out of scope, whether or not it's configured as a breakout or not, because this is just inventory and you're saying, okay, this can be a breakout. So I'm okay with that, because I think once you get to like actually configuring the interfaces, you would know whether or not it's a breakout or, and here's my biggest thing, trunk. You haven't talked about it here, but you use the word trunk port to indicate a single port that could be a breakout, but it's just one thing. To me, when I read trunk port, I think of something entirely different. And I'm wondering if there's a better term for that single port versus the breakout that could be used, that wouldn't be as ambiguous.
Right. You're basically some terminology lineup. Yeah. Yeah. I mean, definitely we could discuss that further.
Hi, Swami from Nokia. So if you can go to the next one. Right?
Oh, the next one.
So why would you say that the non-pluggable is an open issue to be further analyzed? Because I thought that, when you are able to make a distinction between a transceiver versus something that's not a transceiver, right? And you already have a parent-child relationship from that to the termination point. I thought it's already covered. Okay, so I'm wondering what is further need to be analyzed when you already have the port and the transceiver modeled.
The difference is you're talking about this case 4, right?
Case 4, right? So if you go to the next one, right? Yeah. So if you see here, right, you see that there is a modeling for the port component as well as the transceiver module, right? And in a sense both are covered, right? And with this, all 4 scenarios are covered. Yeah. So I'm wondering what's missing.
Right. So the thing with this model is that you cannot distinguish whether it's an empty hole or it's a non-pluggable port like we see here on case 4, right?
But would that not be already determined by whether you have a termination point or not?
Oh,
just thinking loud. I mean,
when you say termination, are you referring to?
Because the point is that in the case 4, right? It's an integrated port, right? So there is a termination point. You don't need anything to be done to that. It's kind of ready, right? Whereas empty hole is just a slot that has nothing.
Yeah. But this is more from an inventory perspective, right? You have termination points. Great that termination points can be created to associate with that. But that's I think that's outside of the inventory. Right? What we are trying to say here is whether or not we need to distinguish these 2 cases. Probably needs some more discussion. But
maybe, right? But to me, it looks the same, right? And to me, from an inventory perspective, the case 1 and case 4 is the same, except the fact that in one case you have an additional transceiver entity and the attributes that are associated to that. I mean, but that's a sense I got from the mailing list. But I'm kind of wondering what's open that needs to be solved.
Yeah, certainly we can discuss this on the mailing list. Okay, so we are. Right. So then we are still having some discussion about the definition for subshelf. So currently there are 2 options, 2 view of the subshelf proposed for the discussion. The one case is there's a single physical shelf, but there's a logical partitioning within the shelf by grouping some of the slots into a subshelf, and this is the first case, and then the second case is very typical. We have a main shelf, and then we have a list of subshelves connecting to through the intra network element cable into the main shelf. So I guess we are still debating, or we're still discussing whether we should cover both options, or whether there's a common definition for both. So I see Nigel, you raised your hand, and do you want to share?
Sorry, I raised my hand, then I put it down again, but I put it. You spotted it. So, can you hear me? Okay.
Yes.
Can you hear me? Okay. Yeah. Okay. Good. That's good. So I think the distinction is that if we're dealing with the physical inventory as a sort of a list, then this one is
Sorry, Nigel, can you raise your voice?
Oh, sorry. Is that any better, or is that better?
Yes. Yes.
Okay, good. Yeah, I'm very close to the microphone now. So I think the distinction is in this case, if we're looking at physical inventory, and clearly in the inventory list, there's two elements, just like the slot element. It's actually physically attached to the inventory, so it belongs to the same inventory item. It's just got divisions, and then the subordinate parts would be in those divisions. Whereas the other picture, if you go to the other picture, this is more of a topological thing. If you can scroll on to the second picture, the second version. Yeah, it's more of a topological thing, so it's physical topology. And it's debatable whether that should be distinct in modeling from just a normal set of interconnected shelves with physical topology between them. So I think that's the distinction. This one is potential. I think we need to represent both. It's just whether both are covered by the notion of the sub-shelf as a sort of a rigid physical structure, or whether they're more. The second one's covered more by topological consideration. That's all. I think that's the distinction from my mind, in my mind, anyway. If that makes sense.
Yeah. So basically, your point is we need to cover both options, right?
Yeah, but maybe they're not both considered as the same modeling strategy. This one's very much of a physically interconnected set of shelves, and the other one is just a sub-element of a single piece of indivisible hardware. So this one's divisible. I can move them around. I could rearrange, put different shelves in different places. Whereas the other one, I clearly can't change the arrangement. It was, cast in the factory, essentially. So that's the distinction in my mind. But we need to cover both of them, clearly. I don't think we can avoid them. But because we're covering physical topology as well, and then this is a physical topological thing. So
yeah, whether you're saying whether for the second option, whether it's considered as a topological rather than putting all those into the same inventory, right?
That's right. That's the distinction in my mind.
Okay. Yeah, I guess we need to discuss a bit more about the modeling for these two options.
Sorry. Bo from Huawei. My question is that the intra network element cable is also in the option of the modeling?
Yeah, so that's, I think that's what Nigel is saying. If we model this as as like physical topology, then the main shelf and subshelf are two different nodes, right? Or two different nodes in the topology. Yeah. The link is between the subshelf and main shelf. It becomes a link, right? Yes. So in that case, how we can do this from an inventory perspective? Do we create two network elements, or a single network element per se? I guess we need to put this together with the topological view.
Yes. So
but also, honestly, from my perspective, right, we also have, there's a typical deployment of multi-shelf configurations, and in a lot of the cases, there's just one network element from a management perspective. So it might be better to just consider this as a single network element and put all the inventory for those shelves all together. But as to how you can build a topology on top of that, that can be more flexible.
My suggestion is that maybe we can consider this in passive inventory and also some enhancement on the base inventory. Yes, or something like that, then we can define that, because at the current stage, I feel like base inventory is important and to progress more quickly.
Okay, yeah, I got it. Yeah. So for the cable between that connects different shelves can also be part of the passive infrastructure. So, Rob?
Yeah, so sorry, I've not been following this work that closely. My instinct here is to model the physical things. Makes more sense. And in this case, you model the physical inventory separately. In the case that you had where you say it's all integrated in one device, that's fine. I think when your suggestion of saying, let's try and just model those shelves as extra parts of that component, I think is a good way of doing it. I'm not so keen in this case of having the complexity of going down to have longer ones for the sub-shelves that's shown there. Instead, I would try and flatten that and maybe have a leaf ref or something to show the relationship between them.
Yeah, I mean, just basically you're saying to put this into a single network element?
Either a single network element or treat them as separate physical devices. And then just have a separate leaf that shows the relationship, saying, look, this is connected at this point. Have that relationship represented somewhere in there.
Yeah, have the leaf ref relationship. Okay. Yeah, that's not could be another option.
Or to say, if it's getting to this level of complexity, maybe this is something that's worth deferring until a future version of the document, as in rules out of scope.
Yeah, exactly. That's the point that we need to decide whether we want to dive into this in this base version, or we can defer it to a next revision. But I see the preference. Nigel, do you still have further comments? Okay.
Yeah, if I came off mute, that would help, wouldn't it? So I was just going to align with Rob's point. My point was flattening it exactly. That's in this case, just make all the shelves equal in the network element and then show their topological relationship. So just to clarify, so I was aligning with Rob's point.
Okay. Okay, so just the next steps, we need to resolve all those P1 issues as we discussed and make some cleanup. So the target amount the design team is to produce a draft and hopefully have it ready for working group last call by the next IETF meeting. And if time permits, we also have a list of priority 2 issues, and we could possibly look into that. And if time permits, we can include this also in the final version for working group last call. And as again, we always appreciate the working group to provide comments and reviews, especially the reviews of the models on the mailing list.
Can you please clarify for the working group what are the priority 1, priority 2 issues?
You mean the list of priority 1 and priority 2 issues?
No, the categories. Priority 1 are the ones, if I correctly remember, the ones that we identified as a must before the working group last call.
Yeah.
Priority 2 are the ones that we wanted to address, but not in this document. Am I right? Do I recall correctly?
Yeah. So basically, yeah, priority 1 are those that we already listed before that must be addressed before the working group last call. The priority 2 are the ones that are important, but we can defer it. We may be able to defer it to the next update.
Yeah, correct. So there is a question from a statement from Med on in the chat. I don't want if I don't know if you wanted to raise it in the queue. You want me to do that? So he was referring to slide 12. He was saying that it does not reflect the discussion on the mailing list with Mahesh in particular, with example of items to cover in this guidance. I'm not sure what Med was meaning. There you are.
Yeah, I think at this point it was clarified, I would say, in the discussion, especially from Mahesh and also from Bo. So I think, yeah, we have good items to be included in those guidelines in the mailing list. So just pick, I would say, the most important of those. But I really echo the comment from Mahesh. We don't need to be that rigid in the way that we are designing, I would say, the guidelines, but just, yeah, provide some sanity checks so that we ensure some consistency the way we are plugging all the various spaces when they are augmenting. So this is the key point, because sometimes, yeah, there is a risk that everyone will include items there in conflicting matters and so on. So as soon as we have these items, I'm fine with that. And you have already good examples there.
Right. So like you said, the model already reflects to some extent a implicit guideline, right? So we just wanted to explicitly state it.
Yeah.
And also look into the example that Mahesh provided.
Yeah, thank you for it. And looking forward to you working with plus calls soon. So I think we have to stop at some point of time. So just to make some progress.
Okay.
Thanks for doing this.
Okay, thank you.
Yeah.
Okay. So I think that's it. Yeah.
Thanks a lot, Ayo.
Thank you.
Next one is Bo, if I'm not mistaken. Yeah.
I think I need to hold it. Just. Hello, everyone. My name is Bo, and here I'm representing all the co-authors to present this network inventory topology model updates. Some quick background on this draft. You can see that inventory topology mapping is quite separate from the inventory set models. Inventory topology model trying to have some mapping with the base network inventory, but also we are doing augmentation on the network inventory to do some bidirectional navigation. So this draft was adopted just before IETF. I made this big. It's 1-to-1, and this draft actually is quite similar like base network inventory. It is intended to be technology agnostic. For example, it can apply to IP network or optical networks, and also giving the NMOP working group currently are defining SIMAP, which is a service infrastructure map. This inventory topology model provide a quite basic one to associate inventory to topology. So that's a quite important piece of SIMAP architecture. So from SIMAP perspective, this inventory topology could support some use cases like service provisioning, like when you provisioning VPN service, you could using this model to associate with the inventory to try to find out whether there are some enough port resources. So under the this picture, we already tracked all the issues we during the working group adoption, and also some discussion also in the GitHub there. So if you want to check, there's there. And this slide is about the whole young structure restriction. The left one is old young tree, and the right one is a new one that you can see we doing a lot of restriction. The most major changes we made is that we added 2 new navigation features to establish one-to-one mapping reference with network elements and port components in the inventory. And you can see on the right bottom part that we also augmenting the inventory network elements with the topology association, like node ref to the network elements. So these are major changes we made in this version. And you can see that we removed the network inventory mapping type. So right now, this model directly augmenting RFC 8345. So that make this model quite flexible. You can use a feature to enable either like 2 ways navigation. You can choose either way. So we think this design allows operators, implementers to adapt navigation direction per their needs by this feature. And the other part, you can see that we removed most of attributes. We think there are some concern raised there by Sergio and Italo, because they feel like these may not be applicable to the optical networks, like system mount point or some policy there also. So in this way, this design provides minimum required navigation. And one issue, this is the second part of the major changes. And you can see that we call it inventory topology, right? But right now we just mapping to the base inventory, that is active inventory. I will just mention, just present it. So this model is not is targeted to try to just doing the minimum required navigation. So if there is some like logical inventory mentioned in the GitHub discussion that like VLAN or something, VLAN interfaces that now we just remove that part. And so thanks for all the good discussions from Italo, Oscar on this new young structure. We feel in this way, this young model is quite fixed and it's trying to fit the basic requirements on the inventory to topology navigation. So you can see there's one small change that we did is the termination point mapping to physical interface name. Before that, we define an interface name list. We're trying to cover like some logical interface, also physical interface, but we feel that could be too complex. So right now, we just doing the one-to-one mapping to physical interface. So that's so in summary, our consideration on this modeling is that we just providing the minimum required definition. And all the other logical inventory or some passive inventory, we are considering that that will be covered by the passive inventory itself or the future work. There are 2 open issues we are currently.
Sorry, can I ask a question on the previous slide? Just a quick question. I'm just wondering, could you please clarify a little why some of the nodes are defined as read-write while others read-only?
Which one? Oh,
you have a couple of documentation.
I think there may be some mistake. Actually, we are reusing the grouping. There's one thing I I forgot to tell that before, in the old YAM model, we actually defined a network element reference in this current model, but since we feel this should be part of base inventory, we relocate this definition to the base inventory. But base inventory, when we are doing the grouping reusing, then there's a read-write. So I think there maybe need some consistency between the base inventory and ours. Maybe we need to define some container to change that definition. So am I explanation clear to you, Qiufang?
Yes, thank you. Go ahead, please.
Okay.
Yeah.
Okay. So I'm just, I need to talk about the two open issue. I like to collect the feedback from working group. The one thing is that right now we haven't, I think we haven't like removed all the passive inventory mapping from this topology model. Right now, link definition map to, there is a one-to-one mapping between cable to link, like I showed on the right-hand side, but this definition could just fit to the direct connection between network elements. But in case there is some more complicated, I mean, that's, I didn't think about those FDT proposed by BBF definition. Maybe that's OLT or some devices like that. There could be other facilities between network elements. So in that way, this link may not be correct if there's more segments, fiber segments between the network elements. So we are suggesting to remove cable name definition. So we try to suggest to the passive inventory work can define that and also define some inventory topology extension if there is a need. So, Eva, you have comments?
Yeah, thanks. Just right. So as you said, the underlying physical infrastructure might not be just containing one single cable. It could be a list of cables, and there's also passive devices in between. So a direct mapping from a link to a cable probably is not the best way.
Yes.
We also have some discussion about, you know, how we, so there's an end-to-end concept of what do we call physical span, right? That is a representation of a physical thing, but in an end-to-end fashion. So maybe one way of doing that is to map the link to the so-called physical span, although we have not come to a concrete definition for that. And yeah, I guess I would rather leave this to the passive inventory to discuss that. And also it may be an option also, like you said, suggested to add some augment for the link between a link to the passive infrastructure within the passive inventory. Yeah.
Okay, thanks you for your comments. So I think we can do that. And the other open issue is that Italo raised an issue about whether this topology needs to add navigation to the interface model. Actually, oh, I'm sorry for the mess. Okay. And what we are thinking about the interface name in this topology model, we are thinking this interface is not device local identification. It should be a global unique interface identification across the management domain. And so that's the reason why we don't direct reference the device reference, like the left-hand side, the CCAM working group draft is working on. Like there is a CCAMP interface reference topology model defined. That model augmenting T topology model and adding a termination point to interface path leaf reference. It's also doing the one-to-one mapping with a termination point. But there's no description on whether this interface is a physical interface or the logical interface. But here in the inventory topology model here, we are thinking this is quite straightforward because port in like the presented by Iowa, that port is just a local some ID, but it may not be that recognizable if there is no physical interface association. And we are thinking the modeling approach is similar like layer 3 topology, also the layer 2 topology. They also identify these issues, so they are using interface name rather than interface reference. So they also proposing still keep this definition in this inventory topology. So, and I'm hoping there's no objection on this definition. Can I ask question to Scott? Because you are you are the author of this interface reference. There is a the. Robert, you are a co-author?
What?
I thought Scott was going to throw in.
So what's the question?
My question is that do you think it's reasonable that we are doing the definition in this inventory topology that we are doing the physical interface association to termination point, but that is not T topology. This is just base network topology of 8345.
Well, this is a interesting question because TE topology is not just about traffic engineering.
Yes.
It has a bunch of other stuff in it as well. I think it's a little misnamed. So from the perspective of network topology and TE topology, I think augmenting TE topology is the correct thing because you get the most bang for your buck out of doing that, in my opinion. So I don't know if that answers the question, but I would augment TE topology in this case.
Yeah, I agree that I feel like this CCAMP T topology is trying to focus on the traffic engineering cases, but this model is trying to doing the inventory resources like mapping or
Well,
some.
right, but I mean,
Yeah.
what I'm saying is that the TE topology model isn't just for TE. It does. There are other things in that module as well. So
Yeah, I agree.
right.
So I think right now we may not have the conclusion on which one is the best way to define, right?
Again, my opinion is you want to do the one that provides you with the most knobs that you can use, and that is TE topology.
Yeah, but I think I will send out this issue to the mailing list so we can discuss more on whether like these two use cases can maybe redundant or something like that, but we can discuss. Okay. Okay. So that's about the last open issue. We try to get feedback. And so that's all from my presentation. And our next step is that we hope this draft with all the open issue we addressed and the model is not that, the model itself has been stable. So we are planning to doing the working group last call with the base inventory model. So still, we welcome reviews and comments from working group.
Thank you. And just a clarification, if I'm not mistaken, you said that the T topology is a C-camp document. It's a TIS document. Next one.
Do we have Diego now?
There is.
Okay, good.
Daniele, I guess I'm big enough. You don't need to go into the to get so close to the screen, I guess. But anyway. Oh, thank you. I'm big enough and dressing in red, so I should be very, very visible. Anyway, well, the the point is that introduce a new attempt of trying to address the issues regarding entitlements, etc., that has been around for quite a while. And we have tried to follow the feedback that we got from the last meeting about the whole thing being a little bit too complicated, at least too complicated to start with. Because when you start discussing about this and all the particular cases, things may become extremely complicated. Probably is not the best solution to try to address everything at the same time. So the idea is we have rewritten the draft around trying to make it the whole thing easy to understand, go to the basics, and try to solve first the basics and then add features and different material as we analyze more complicated cases. So to start with, the document and this presentation is about the basic concepts. The basic concepts is that for whatever the goal of an element that we have in an inventory is to build services, and this is something that is those services are built using the features that those elements provide, whatever they are, and those features can be of any nature, can be hardware, can be protocols, options of the protocols, algorithms, pieces of software that are extremely sophisticated, AI, you name it. But those are the features, and those features normally require, in most cases, specific permissions. Well, in most cases, in all cases, they require some kind of permission. The point is that some of these permissions are implicit because the requirement to use a router, to connect a router, is that you have to have it. If you don't have it, you don't have the permission. So you have to buy it, take it, move it, install, etc. This is essentially implicit and is associated with the acquisition of the inventory elements. Note that I'm not using here assets on purpose, just to avoid further discussions. And there is other cases, and most of the cases as well, is about that they are explicit permissions that are required. The typical thing is a license. You have a license, I give you the permission to use this version of the software, I give you the permission to activate 100 gigs in this board, etc. For this, the idea is to use two terms. When we're talking about the features, we are talking about capability. Those terms are taken, if I remember well, from the Webster and Abridge dictionary. So capability is the power or ability to do something. Well, it was one of the meanings. And then you have entitlement that I found extremely interesting, that you can, according to the dictionary, you can pronounce it entitlement or entitlement. That is something that, to me, was... I'm looking at at my advisor in English. It's something that curiously is accepted, but let's call it entitlement. That sounds more natural, which is the right to do or have something. So you have the capabilities, you have the feature, the entitlements, and the model uses that. What we're proposing is that to model the features, what you can use to build the services is a capability. What the permission that you need or that you will have to show to use those capabilities are the entitlements. And both of them will be part of the augmenting network element in the basic model. So the modeling capabilities is that the idea is that any given element that is for sure should include the list of its capabilities. In this sense, probably it sounds that a cable should have capabilities, but again, they were talking about those implicit capabilities. That this is something that probably we have to if we want to be fully follow a full logical derivation of this, we have to be careful about that. And this is something that I noticed when writing this, not when writing the draft. And the idea is that the list of capabilities, for sure, we consider that you may put all the capabilities that you have. You can have a total list in your inventory, because that may make sense in your inventory to have a list of everything you could do with it. But in any case, you must have everything that you actually can do in that moment. And that, the main characterization with capabilities is that they may be restricted on the availability of the proper environment, entitlements. So that include which are the entitlements that apply, and in some cases, which are the restrictions in terms of the duration, or in terms of the it can be used in this range of bandwidth, etc. That's one thing. The other model is on entitlement, and for this, what you have is the list of applicable entitlements, and we are considering two ways of associating an entitlement with a network element, because you have what we call attachment. An attachment implies that has been assigned by another party, typically the typical license server that is commonplace in many places, or that they can directly include the entitlements because they have been installed there, or they are associated with things like, for example, a site license, that is anything that is in this room has the right of using, I don't know, whatever the version of MPLS. The point is that makes that entitlement can be listed in multiple elements. It can be listed in the target element and can be listed in the a license server. Basically, we have a long list of entitlements it's serving. And the attachment is the connection between the real element, the element providing the capability, and the element that is providing the entitlements, the license server, is defined by the specific container that we call, which is how we call it. Is the I should have this. Is a dedicated container? Oh yeah. That is called entitlement attachment. Sorry, that's I didn't see it for a second. So again, those entitlement attachments may have limits and data about which is the entitlement holder of that particular one. Simply that's what we're proposing to start with. Then we can start to discuss how we are going to model things like the combination of these with an open source license, or what happens, what you have is something that lasts for a limited amount of time, what happens with licenses that imply a limitation that you cannot use another element, which is something that originally we sort of tried to address at the very beginning and made the thing a little bit too complex. So the common status, and I finish. Well, the model, and this is something Bo mentioned when we met this week, is that the model is just using the tree. We have not gone into defining the elements, etc. Basically, because we want first to get some feedback. And if the group feels that this is the way to go, we will start working on it. And this is why, to show you, well, this is the idea. And right now the document is up to, this is the idea. If everything seems reasonable, well, the idea is to make a formal description, to address any comments that we collect here on the list, and well, with this, prepare a complete version, and think that probably adoption could be considered, though that new version, well, this is a 0.0, there's going to be a 0.1. because we decided that renaming the draft was a wise sign to show that we were trying to restart from all the original problems. And that's all.
Yeah, Swami from Nokia. One of the questions I have is that in terms of the capabilities, do you think that the network element is an entity that's a starting point to describe that? Or would it make sense to have it at a higher level in the sense that I can have something which is of a network, right? Or in a sense, like this is a portion or a sub-network where I want to have that, and one of the entitlements could be, how many network elements I can have, as an example, right? So I like the definition. It's just that my feeling is that when you build the hierarchy, right, it may be at a higher level, and then you can iteratively drill it down.
That's a good point, and this is the kind of thing that we would love to hear, because, for example, supporting this kind of hierarchy of capability aggregation or which is the integration is something that would be interesting to address. But again, it's something that to start with, we prefer not to go.
Now, I'm just wondering what the starting point could be, right?
No,
I mean,
but you're right.
Because to me, network element is good, but network
the important point here is that what we have in mind is that since we are dealing with the inventory is precisely something that can be inventoried, So the idea is that a sub-network is something that you cannot say, that's something that this can be, You can't say, I have bought a sub-network. Yeah.
No, that's true. And the other thing is, as a kind of a related question, is that in terms of the inventory and assets, do you only look at the network, but also include the controllers, for example, right? So you could have capabilities in the network and capabilities in the controllers, and I mean, they could be distinct, but the principle still remains the same, right?
Basically, frankly, to me, the controller is part of the network, but that's something that we can discuss.
That's okay. That's okay. But it's similar, but the capabilities and what.
The kind of capabilities would be different. That's.
So first of all, congratulations! You managed to fill up the queue. I've never seen a queue so long.
So do I deserve any prize for this, Daniele? So some kind of medal or something like that.
So just a probably dumb question. In slide 5, when you showed the model for entitlement, I noticed that it's all read-write. But if it describes what the network can do, shouldn't it be read-only?
Any sorry?
So the model for the entitlement is all read-write. And I was expecting if you are describing what the network can do, it's something that you can read but not write. It's something.
The point is that whether an inventory management system can make changes. Whether what we're doing is that's a good point, because it's whether what we're doing is exposing what you have, or you can modify what you have with the same model. This is something that, you're right. I guess that someone is taking notes, and this is something that we will try to address. Yeah.
Okay.
Mahesh speaking as a contributor. I had a really hard time wrapping my head around the draft, and I had to do nothing with the English aspect of it. I think you got that right. So I had to jot down like a couple of my points. The first one actually was what Daniel just mentioned, which is everything in the model is read-write. Whereas I would have expected at least some of the notes to be read-only.
Okay. No, that's something that has to be.
Because it's a capability that you're reflecting. You're not allowing for configuration.
You're not supposed to be configuring this. Here is about, well, yes, that's something that you're exposing. Yeah. That's something that's. All
right. But backing up, so going through the draft, and one of the difficulties that I've always had with licensing schemes or entitlements, if you want to call it that, in NOS, a network operating system, is what entitlements should I acquire to get a specific capability? Mm-hmm. So I'll give you an example. It's if the customer ultimately wants to deploy a point-to-point service, and they're just trying to figure out what licenses or entitlements I need to acquire to set up that service.
Wait, one question. Who's the customer here?
Oh, sorry. The customer.
Just to understand the.
Right. So the customer is an operator.
Okay.
That is offering to their customers and enterprises an ability for them to get a point-to-point service. But what they need to get from the vendor is the set of entitlements that will enable them to offer that service. So what are the list? One of the questions, obviously, is, do I need routing entitlement? What kind of routing entitlement do I need? Do I need protocol support for EVPN, as an example? So is the idea that people will be able to figure out what set of entitlements they need to offer a particular service?
I would say no.
Okay.
For a very simple reason. That depends on the business model of the different technology providers. The point is that if I buy or I'm planning to use boxes for provider X, they may have a policy in which they require a specific licensing for each one of the options of the protocol. Another provider Y can have a commercial relationship with me, not necessarily their general policy. The commercial relationship with me allows me to use it in a much more straightforward way. The point is that what you should be able to check here is whether, when you are trying to activate a capability, whether you have the entitlements. Not what would you need. That depends on the commercial policy, and I personally believe that we should not reflect that here, because it's something that is, it's fluid and has connections that have not to do with the technical support. It's about we make a deal for whatever the reason, or my CEO plays golf with your CEO and they make an agreement, and this is how you reflect that here in a model. Seriously, the point is about what you can do and whether you are entitled is something that you should be able to check. How you can get entitled is something that I find, first, very difficult, and I'm not that sure that should appear here.
Okay. Moving on. The choice of augmenting network element and not network inventory model, what kind of drives that?
Because the IDS capabilities are associated with the elements and not with the inventory at large. Yeah.
Okay, just to be clear, that's the intent. So I'll stop at that. Thank you.
Good. Yeah, so just following the discussion, you said for the capability, you start from network to element. And also, like Swami asked, if you are drilling up, right, to a subnetwork or whatever, have you also considered drilling down to individual components?
Again, that's something that we have in our discussions. We have mentioned, but we have preferred to not address yet, because we wanted to avoid. I mean, my real concern was coming here again with a model with a lot of different references pointing here and there and allowing containers that would contain other containers and referring to the outside. So if within this necessary, and this is something that we could do. The point is that it's about identifying which are the components and whether the capabilities are associated to the components, or that means that we need to get deeper when analyzing this. Normally, my understanding is that the common practice is the capabilities are associated either. In the case of hardware, they are very much associated with the physical elements. Case of software, it probably is a little bit different because you have potentially several layers. You have the operating system, you have the application, you have a set of libraries, and there probably it would be very difficult to avoid this component capability. In the case of purely hardware, probably not. I mean, frankly, I don't see the need of declaring capabilities for a cable or declaring capabilities for a rack. That's something that, well, they should be obvious. No?
Yeah, definitely. I think it's use case driven. So,
but
you have this thing.
But for sure, when it comes to software, we will have to have this in mind. I'm totally sure.
Huang Wei, I have this entitlements and capability is only a network model. It's possible a device model.
I think it should be associated with the device model as well, but taking into account that it's not about going into digging deep in the structure of the device.
Yeah, but I'm not sure whether device can directly support a capability.
Well, I mean, a device that is, for example, an optical switch that is able to work at different lane rates and that is controlled by licenses.
Okay, that's for my first question. And the other question is that I see there's the entitlement has two parts. One is entitlement list. Maybe that should be read-only. But the other part, it seems like there's holders. That seems like is that just for annotation or something?
No, precisely that is that part of that container in the entitlement model is about precisely listing who is owning an entitlement that has been installed in a server. So you're right. Probably the upper part, so to say, should be read only. The lower part, the one that talks about the attachment, should be rewrite because it's going to be changing in the model. Yeah.
Another question is about the attachment on the components. I don't see there is a reference to the capability, but you just reference to the components. So you are thinking the entitlement.
The point is that in all cases we are trying to make it as a reference by name. You're not pointing to the capability. You're pointing to the entitlement that is connected to the capability that lists the necessary entitlement. But if you think that this would be easier, this is something that we can discuss. The point, and well, and you know, it's not hasn't. I don't know if it has been here or elsewhere. The discussion about the double cross references from the inventory to the CMAP, etc. The problem with this is that keeping the consistency can become a nightmare. Very often in the model, I'm not talking about the database, because here is always something that is important is that we tend to, or at least I have seen in some cases that many of us tend to, instead of doing a model for exchanging information, we try to make a model for building a database. And we have to be careful about that, because in the database, making all the cross-references is fine, because that helps you in finding, but in the model, probably very often that transforms into a nightmare, because you have to keep the whole thing consistent. So in my view, as long as you can find, you have no, I don't want to say a decent, you have a pointer that is sufficient to derive the whole information. Personally, I prefer to go that way and to keep things simple. But that's something that we can discuss for sure.
Yes, I think we definitely can discuss. Yeah. Okay.
Thank you.
Right, Nigel Davis, Sienna, sorry. I fully agree with your point you just made about models for exchanging information and models in databases. I've had that battle for years, so I fully align with that point. But on the main body of the work, I strongly support the work, which I'd like to participate in. So to show you how strongly I support it, and I've been working on this sort of model for rather a long time, actually, which we can talk on when I start participating. But it aligns very much with the work we did in ONF TR 512, and which is now in ITT G7711 in the specification model, which was statements of capabilities of things. So we considered sort of capabilities of any provider, although we did focus on particular things, which I'll talk about in a moment. And we saw capabilities sort of being available to planning, to purchasing, to running operations, etc. So at any stage in the life cycle, because they seem to be critical at many stages. We drew up some pictures which intertwined capabilities with intent and expectations, so we could sort of understand how to express those in terms of capabilities as well as actual things. But we found it extremely complex when we started trying to model capabilities. We found it was a deeply nested and structured model. We actually looked at models of capabilities of terminations and connections and devices, but at that level of detail, and also compatibilities of equipments in slots and so on. So the functional physical model, we try to generalize the capability model to be capabilities of components. We sort of got somewhere with it, but it was difficult. And we looked at expression of capability as a general thing. We found that very challenging. It sort of looked, when we were doing it, it looked like a mixture of Yang-like statements with constraints, but also JSON statements of absolute values and so on. And we looked at the interrelationship as capabilities became more restricted. So we considered, we didn't do very much on this, but we considered what we called operating rules, which I think align very much with your entitlements. So what the operator allowed to happen. So it's got that sort of feeling of restrictions. But as we try to sort of relate to the capability model to the restrictions of capabilities, that got quite challenging, which seemed to be a recursive sort of thing you could do. And then when we ran into various other patterns that seemed to be very interesting. But the reason that was the reason I bought, I mean, about 3 years ago now, about 2.5 years ago, I bought the modeling boundaries draft into IETF, was because of the challenges we'd have with capability modeling. So I try to highlight in that draft the twists and turns we've been through and what that then yielded sort of in general patterns and so on. So I can bring, I don't want to bring too much because that's too many things to bring in one go, but I can bring some of that to the discussion or try and explain where we got to with it. But it is published in G7711 in the appendix or annex that relates to what we call specification. There's a lot in there. I said it's also in ONF TR512, but ONF is disbanded now, so it's the main source of this is in G7711. So if we can pull some bits out, there's certainly some insights in that, and some pain. There's other things in there, but so that's basically what I want to say. So I strongly support the work. That's the end of my comments.
Well, first of all, if whatever the experience with that you came from your previous pains with ONF and the capability model will be more than welcome, Nigel. The point is that we are trying to follow, I mean, rather than building let's say a full, well, I'll use the word, a full ontology about what you can do with a router, etc. What we tried is, or what we have in mind is something that tries to be a little bit simple, is about what you pay for, which is my idea of an inventory. I have paid for this or for that. we call it a capability, we call it an entitlement because it sounds well, but it's basically what you bought. That is, Jan has limitations is something that, well, we were discussing in other groups, and you know that in MMOP, sorry, it's MMOP. I always forget about it. We have the NMOPs meeting and the MMOP. And in MMOP, we have been mentioning here and there that we are reaching the limits of Jan for certain things that we want to do.
Yes.
Why not? I mean, probably that doesn't belong here. It's more for MMOP or for elsewhere. And this is something that probably I would love to start discussing about this. So well, you are more than welcome. I mean, I would be really glad if you are able to bring some of your pains and solutions from ONF. And if you're thinking about starting some discussion about the limits and how we can move beyond those limits of Jan, well, this is something that we have started to reflect as well. So let's go for it.
Okay, great, good. Thank you.
Okay.
Joe Clark, Cisco. I guess speaking as a vendor who tends to like licenses, I guess we need this. But I'm with Mahesh. I cannot wrap my head around some of these things. For example, without the model there, just the trees, maybe that's what's difficult. To me, it seems like, and I think you tried to answer this, you'd start both trees by saying this augments network element. I would think capabilities would have the component ID. Like I have a capability that's bound to this component because software is going to be presented. There's an already adopted software draft. I have a capability for this piece of software that requires this entitlement. But I will say, because we're probably already short on time, if you take some real concrete examples, not abstracted, blah, 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 but pick like some Cisco, some Huawei, some whatever, model, show us in your draft how that would work. I think that would help my head at least figure out, is this sufficient and what's the right thing to do there?
No, that's the idea. I mean, that's what Camilo was working. Camilo, I don't know if Camilo's connected because for him it's going to be 2 a.m. or something like that. So, but he was working on some examples, and we decided to first bring the idea, see whether we didn't get too much pushback. My feeling is that not. So it's we are going to continue exploring this, and the idea is to bring some examples, finish the model, and well, hopefully in Madrid there will be, well, in Madrid or even before, hopefully before, we're in the position of showing something more detailed, taking into account that, again, you seem to be not very unhappy with the idea. That's it. Oh, Nigel again.
Yeah, sorry, I was just going to. I thought somebody said at the beginning we didn't have a full agenda. Then Diego arrived, and then we now have a full agenda, don't we? So just supporting Joe's comment on examples, that proved to be critical when we were trying to work through this in ONF. I mean, the model in abstract is all very interesting, but it doesn't sort of mean anything at all until you start really laying out examples, and then the complexity starts to come out very quickly, and as you start to try to lay the examples out, it's extremely hard. But it's absolutely critical, though. So I fully support Joe's comment on that.
No, that's my hope and my fear, I would say. Oh, you're there. No.
Can you hear me? I don't know.
Yeah.
Yes, to Joy's question. So yeah, we in the previous draft, I don't know what happened with the previous draft, whether this is this over this one or this is a new one?
This is a 001 new. Yes.
Okay. So the other one had examples of what we're trying to solve comes from actual work problems of modeling licenses in. I personally haven't run Huawei in my life, but Nokia, Cisco, and Juniper. There's an example from Huawei from the internet. the biggest, more complex example that we're trying to model is one in Nokia, in which you pay as you grow router. And basically, this means that a breakout port, for instance, doesn't work if you don't have a license. And we have examples all of that. Of course, it adds complexity, and I mean, that's real life, but it will be up to the group whether you want to actually model real life, real networks, and embrace the complexity, or don't. I mean, because it's going to come with just doing the modeling of all of this. But yeah, we have examples. At least we can add them at convenience, but they might look complex.
Yes, so in some senses, Joe said the same sort of thing that I was thinking when I was reading this, is that I find it hard to get my head around exactly what this is. And I was sort of thinking about like the inventory model, also the open config inventory model. They have a structure which is very sort of common and fairly simple and allows you to model complicated things. But then by doing so, you have a lot more complexity in terms of what ends up being built, because it can be built in so many different ways in different shapes. Whereas what you have here is a more concrete structure, and you've already predefined some of that, but it makes this look more complicated because of that. Now, I think it probably comes down to is you're just modeling a complicated thing, and it's hard to avoid that complexity. I mean, obviously you want to try as much as you can.
Well, I guess that the point is that if we can, and it's my view, this is something that maybe Camilo has another view, or Marisol. My point is that I do believe that such a big number of cases can be dealt with something that is simple. It's basically you have a piece of hardware in which you're running a number of software elements, and you have the software, you have licenses for the software, or for several ones of those software elements. You have the piece of hardware that might be require some particular enablement for a particular feature in one of the hardware, and this is something that with this should be. Then you start with what Camilo was mentioning about a license that is a pay as you grow, and then how do you model this? What I would say is that for the initial examples, we can show that this could solve most of the, let's say, usual deployments. And then if we need to add other mechanisms for addressing this, I guess that is even for the group to decide whether it is worth it to go for it, or say, well, we know that we cannot model everything in the universe, but we are happy with this. That's my...
Yeah, and I think for me, the feeling is more on all these things we do in IETF and things is to try and solve 80%.
Yeah.
You know, if you can get a simpler model that solves the 80%, then that's a good enough, certainly as a starting point. And then you realize exactly which of those more complicated cases are worth solving, and which ones you can find a way to, fudge them in a way that's good enough without adding the complexity everywhere. So that might be worth considering.
I guess that we're in violent agreement on that.
Thanks.
Yeah, so just Camilo from Entity here. So yeah, but because you don't have in your network these Nokia devices in which you buy licenses to expand the bandwidth that a port supports, and this is not something that comes from. I mean, this is something that we have in the network and is running right now. I mean, it's not like. And Huawei supports all of this. You can buy a license that you can distribute in 5 different devices to expand the bandwidth. I mean, that happens. So yes, that you cover the 80%, it doesn't mean that the other 20%. Well, when the other 20% is are corner cases, right? But this is happening in my network, and my network is not the more complex network in the world. It's an ISP big network. It has simple elements, and it has that. So, well, I mean, we can try to offer our experience on what is there. I mean, you can give us ideas how to model this, but you will know, you can intuitively know that this is not going to be simple.
So just to respond to that, maybe 80% is like that's setting the bar too low, but it's like of how many of these. So maybe it's 80% of deployments. You know, if is that sufficient? Does that make the problem?
That's where when that's, I guess it's up to the group when we declare consensus and we declare that this is enough. And we can come, because it's true, Camilo said it, we have much more complex problems. We can come and show you the complex problems, and then we can decide whether it should be there or it's better that we wait till we make another implementation in the future. For example, that's something that we have to, I guess that this is the typical decision how you face things.
Thanks a lot, Diego. Probably good time to move to the next presentation, and we have 20 minutes left, so we leave some room for presentation and discussion.
Okay, hi. So here I'm. So here I'm providing a status update on the on the draft for a model in passive inventory. So we haven't updated the revision yet because it's still 0.0, but hopefully we'll get an update coming out soon. And this discussion is to reflect to share with the group some thoughts process we have done since the last IETF. So basically, we recognize that the inventory management for passive infrastructure is of really good interest for different segments of the network. And so what we are trying to do here is to develop a common model to support a variety of network scenarios. So we have weekly discussions to align the objectives and terminologies. And we have seen a lot of contributors joining this work with different technology background, which is really good, and we appreciate it. And also, we received quite a lot of input from especially the Broadband Forum on access network modeling, because there's a lot of there's a heavy access infrastructure that needs to be modeled. So we clarified a bit of the types of passive infrastructure we are looking to cover with this model. And we reviewed some scenarios for optical access and OTN and DWDM transport, as well as an initial proposal for microwave transport. We are still missing some experience in looking into the IP or packet domain use cases, and we welcome anyone with this experience to come and help with the input. And then the agreement is that this model should cover all the above network scenarios. So this is a quick drawing of the passive infrastructure for the access domain, as we are using this as an example to guide the model design. So within the access infrastructure, we have what we call the OLT, which is sitting in a central office, connecting to a bunch of customer, basically the customer end devices called ONUs that sits in each individual family, right? And the network in between the OLT and the ONU is called ODN, Optical Distribution Network, which can consist of a whole bunch of passive devices along the path, and it is sitting in the middle to distribute the fibers and to perform all those fiber splittings and distributions. throughout the network. So so there are many different types of passive devices. So, for example, the optical distribution frame that sits in the central office that aggregate fibers coming out of the active devices like OLTs onto cables going out to the field, and then there's a fiber distribution terminal, and when it which connects what we call the feeder cable to the rest of the fiber infrastructure. And not only that, there could be multiple stages of fiber splitter towards the end user. And so this is basically, and for the cables that are connecting all those passive devices, each of the cable could may not just be a single cable. It could be just a concatenation of cable segment which are connected or spliced with the joint box. So basically, all this passive infrastructure, we need to model it and expose it for the management. And then also similar to what is seen in the access domain, we also have similar passive infrastructure in the transport, right? Except that it may not be that point to point, point to multi-point. Most of the connections are point to point between two transport systems. But still in the middle of the field, there could be places where fibers are routed into different places, and those are also the passive infrastructure that we need to model. Also, we have some good examples, good input for for a potential passive infrastructure in the microwave domain, and that which we still need some further discussion because it was just proposed before the IETF meeting. So we need to look further into that. But note that the kind of devices in the microwave field could be different in shape and especially on those antennas and whether whether we consider the microwave the spectrum as a part of passive infrastructure. That still needs to be discussed. So we did a bit of clarification on the terminologies. The first is the passive component. What we say is a passive component is actually a physical component that is undetectable, which means it's not active. You would only be able to get the information through manual input or some other means. And the passive component could be both inside or outside of a network element. Right? And at this phase, we're primarily looking into the passive components that are connecting to active network elements, and the modeling for passive devices within a network element can be the next step. And so also for the cables, the definition we currently have only covers fiber optical cables. Whether we need to make it more generalized to support other type of cables like Ethernet or electrical cables, and in the case of microwave, the microwave waveguide, that needs to be further clarified. Also, in the case of fiber optical cable, it can contain multiple cable segments, and they can be connected or spliced through the connectors. But the main point is a single cable from end to end will consist of the same number of fiber cores, and that's how we consider it as a single cable object. And also, a cable can consist of multiple fiber cores. A fiber core itself is basically an unsplittable. I don't know if the English name is correct, but it's basically undivisible physical line, which is contained within a fiber cable that can guide the light through. And there was also, in the discussion, there was also a term called a strand that was proposed. We also put it into the comments, basically indicating a fiber core is sometimes considered as a strand. Also, we talked about an end-to-end concept about a physical span. Basically, a physical span, it's representing an end-to-end connectivity between the two inventory ports sitting on the network element. So if we look from more physical perspective, this physical span is rather a functional concept, and it's not a inventory concept. So basically, it's out of the scope. And the physical span can actually be point-to-point or multi-point to multi-point, which can be further modeled as a link, as a topological link, with using the network inventory topology model. And the similar concept exists for both access and transport. So in access domain, there's a term called pan-optical path, which refers to the end-to-end point-to-multipoint or multipoint to multipoint path between the OLT and a bunch of ONUs. Do you want to?
Mahesh, I definitely would agree with your point on the cables, that the definition currently, I was confused why the distinction between an optical cable and other passive devices. So if we can generalize that to all passive devices, that would be good.
Yeah, thanks. Yeah, that's actually one thing that we will wanted to do. Okay, and so also there were some discussions about the modeling methodology. Basically, there are some mixed notion about topology and inventory. Which part of the information, which part of the model we may consider it as a topology, and which part of it we could consider as actually an inventory, right? Also there are a lot of discussions on the mailing list, and so as of today, right, we have two things. One, a topological concept is probably related to how, for example, a cable or cable segment is connected to ports, or to the two active ports on the network element, or to a passive device. So basically, this kind of connectivity and this kind of association between the cable and the passive device port could, whether that is a topological concept, it can be modeled by means of a topology, that needs to be further discussed. And for sure, from an inventory perspective, we could model all those passive devices and component itself with as a inventory object, right? But for the current version within a passive device, we have what we call A-end and Z-end, which tells how the passive devices are connected to each other and to a port. The argument is rather how this information, whether this information needs to be modeled in the inventory, or it can be modeled as yet another topology layer above the passive infrastructure. So, and yeah, and that also then gets to the second point: how to connect passive inventory to a topology. Whether we need a layer of physical topology to describe the topological aspect of the passive inventory, and use the network inventory topology for the mapping. Right? There's also additional consideration, I think, in CMAP to whether the topology hierarchy, I don't know how it's called, topology hierarchy or layered of topology, should include also the passive infrastructure. And I recall the conclusion is that it should be, it may be included, but as an optional layer. So to this end, we need some more discussion to conclude this modeling methodology for passive infrastructure. And yeah, so this is just one of the proposals we had in the discussion. Probably not worth going through as we, yeah. Also, there's a comment about whether we could have a unified way of modeling passive devices and network element, whether a passive device can be actually considered as a new type of inventory object, right? Basically, yet another type of network element. And this probably depends on the definition of a network element. And you know, we have the definition of network element, and also a physical network element. That a physical network element is an implementation or a specific group of components, hardware components, whereas the network element is a generalization of the physical network element definition. So I guess this probably needs to be further discussed to clarify, because if we include a passive device, if we model passive device as a network element, there may or may not be changes in the definition of network element to cover that. And just to clarify, the 0.0 version today, it does not model the passive device as a network element. It's a type of its own. Also, there are comments about developing some examples to describe the different types of passive infrastructure, and we also believe that it is very helpful, and will build some examples based on the network scenarios that we just shown for access, for transport, microwave, and hopefully for also in covering the IP network. Yeah. So the next steps will hopefully giving a 0.1 revision update. To address all the issues, and since there's a lot of interest coming from the working group, once we have the revision update, we'll probably be ready to request for a working group adoption call. And in the meantime, we'll very appreciate reviews and comments from the working group on the mailing list, and also we are more than welcome to join this work. Yeah. Okay. That's it.
Any comment? Any last comment before we close the session? No, it seems not.
Good.
Okay. Thank you, Ariwa. Thank you, everyone. Enjoy your lunch. I will enjoy 1 hour and a half of sleeping, and I'll be back. Thank you, everyone. Bye-bye.